Well, good morning. As you can see here, we are now on Thursday, August 13th. Today we are going to be talking about your lab that was assigned yesterday, which is due next week, Wednesday, and we will be covering section 3.2 on velocity and acceleration. You might remember from the introduction, maybe from the first day's video that I sent to you, that I talked about doing 2 sections per day, and you might notice that on our calendar here that for at least the first 2 weeks we're doing just 1 section a day. I think it's a good idea for us to start a little bit slower. These are difficult sections, ease into the physics, and then you can see as we get into chapter 5, you'll be covering 2 sections per day on many of the sections. I've got your first 3 labs written, and they've all been sent out to you. As we move into chapter 5, I'm still working on getting all of that figured out for at-home labs using equipment you have at home. Hopefully you've read through lab 3.1 already and kind of see this pretty easy. And if you look at 4.1 and 4.2, you might actually even see that there maybe you can even consider them a little bit of fun. Like 4.2 requires you to actually make a device so you can measure angles. So today we're going to be talking about section 3.2, but before we do that, let's talk about the lab, because some of you maybe got started on it and are a little bit, apprehensive, a little bit anxiety as to what exactly do you need to do. Okay, so first of all, it was assigned yesterday and you have a full week, so it doesn't mean that you have to get it completely finished already. But of course, I will take it at any time that you want to turn it in up until next week, Wednesday at 8 a.m. After that, it will be late. I'll still take it. There will be some late penalty points, though, that will be added to it. I want you to complete this in a notebook that is kept separate from your notes notebook. This is our lab notebook. As of right now, I don't know exactly what to do for getting you a lab notebook, but hopefully there'll be something coming out soon where you're going to be able to come in and pick up textbooks, and then when you pick up your textbooks, you can also pick up a lab notebook. You'll ask the librarian for it, and he'll know that I provided them. Until then, if you do them on a separate piece of paper, that's fine. And if we end up having a what we'll call the COVID edition that goes in our lab notebook, I like you to keep a lab notebook because of the fact that someday when you get to college, some of these labs you're going to repeat. Probably not the one that you're doing over this week, but many of them will be things that you'll see again. So being able to reference back and get some of the answers, whatever, could be helpful. So anyway, so that's a lab. If you have any questions on any part of the procedure, please don't hesitate to email me and tell me so that I can fix anything. I'm writing these at home over the thoughts in my head about how this would be conducted, but I don't know your scenario at all. So therefore, if there's anything that you need clarification on or help with, please don't hesitate to email me and let's get it straightened out. All right, so let's see here. Of course, I did not open the notes for today, so give me a quick second here. This will be fast. All right. Is there anything else that I need to address with you? Also, I should point out here on my website, you can see all of the resources that were in the chapter 3 and 4 supplies here. And then, of course, on Classroom, I pushed out a classwork file that has all 5 of those as well. So everything should be out there. And also, by the way, I'll say this a few times because this is very disjointed for me too. If you find any mistakes on anything, please let me know. What I do is I tend to give people extra credit for pointing out my mistakes so that I can fix it, be it a spelling error, I cut and pasted something and it doesn't make any sense. Let me know and we'll get those, give you extra credit for that. All right, today's notes. First of all, the homework assignment from Monday. You should have already turned this homework assignment in. It was due by 9:45. It's my way that I'm taking attendance for Thursday. So if you, for some reason, weren't able to do the homework assignment, you need to email me personally and let me know that you are here and that you are participating in Thursday's lesson so that you can uh, get your attendance taken care of. You had 4 homework questions, 3 of them dealing with distance equals velocity times time, and then 1 of them dealing with the metric conversions. In these first 3 questions here, of course, when you see this on a test, it doesn't necessarily say that it's a distance equals velocity times time question. So you have to be able to come up with that. And my suggestion for you is when you're solving these problems is start by looking for a question, right? So when it says, what is its speed? Of course, we should be able to recognize that speed and velocity are interchangeable terms. And so you might be thinking, you might even write down, I get partial credit for things you write down, the V equals question mark, because I should give you partial credit for that because now I know that you know what it is you're trying to solve. Then you might also go in and write down that 45 seconds, of course, that's a time, and that you recognize meters. It doesn't say the word meters, but it does say covers, it doesn't say covers a distance of, but 1.5 meters sounds like a distance, and now we can see our variables coming together. So when we solve for velocity, distance divided by time, 1.5 divided by 45, and we get 0.073 meters per second. Remember, the units are important too. I don't grade them on the test, but I appreciate them. In AP Physics and in college physics, you can expect to be graded on them, so it wouldn't hurt to practice now. In question number 2, a bicyclist travels 55 kilometers in 1 hour and 30 minutes. What was the bicyclist's speed? Okay, so first thing is they don't tell us what units for the answer. So if you decided to use kilometers per hour, that would be fine. You would just take 55 kilometers and divide it by an hour and a half. Of course, as you put that in your calculator, you'd write that as 1.5 hours. That would be fine. It doesn't say that we can't. Now, on the homework assignment, so if it does say put it in meters per second, you can see I already did the metric conversions. If that's confusing you, we'll get back into that as soon as we talk about the metric conversions in a moment. And then to get out of hours and into seconds, I think I addressed that on Monday, but if not, just notice what I did here is, you could get out of hours into minutes, get out of minutes and into seconds, but in the end, it's that number. That won't happen on a test. So in the end, if it says 1.5 hours on a homework question, you can Google it. 1.5 hours is how many seconds? Google will do it for you. So that is a distance, that is a time, and that is a question. When you take those 3 variables, it looks like we're doing exactly the same thing we did in question number 1. And so we end up with 10.2 meters per second, which is about 23 miles per hour. Question number 4. This topic is actually part of today's notes. I don't recall that I did this on Monday, but it's okay. You might have figured it out. If not, not a big deal. When I'm checking off your homework, remember you're taking a picture and sending them to me, I'm not checking for accuracy. I'm checking to see that you did the problems I assigned, that you're not trying to pull a fast one on me. But as far as getting them wrong, there's no penalty points for getting questions wrong. So if you couldn't figure out question number 3, you can always email me, or you, of course, could go back and check the work with the answers that I have provided. Fix your problem if you want to. You don't need to. Remember that the point of the homework is just to prepare you for the test. Yes, you get your 2 points, but those are measly compared to the test question points. So, on a typical test, if it's worth 100 points, this question by itself is worth 10 or 15 points, just as one question. So we do need to know how to do it. So looking at my stuff is just fine. All right, so, first of all, money question. We're still solving for what is the speed or velocity. And we pass a sign, and then we pass another sign, and both of those have kilometers in it. So we know that's a measurement of distance. In the context of this problem, we'll see it today. I'll draw a picture out for you. Is that you go from this is like, we're going to call this in today's notes a D initial, and we're going to call this a D final. All right, so this is like you pass this sign, then you go to this sign. What's the distance between those 2 signs? So we just subtract. 89.6 kilometers becomes 89,000 meters. 1.25 hours, same thing as we did above to get that into seconds. And then we solve. And if that eludes you on a test and you use one of these distances in down here, so if, let's say that you had put 115,200 meters in instead of 89, you're still going to get a very good partial credit. Because remember, the point of the physics is that we understand how to solve a problem. You didn't catch the whole context of it doesn't mean that you're going to get a 0. On a question like this, if this is what you did and you showed your work, stuff like that, I imagine I'm still going to give you 4 out of 5 points or 8 out of 10, whatever the question's worth. You're going to get good partial credit for it so that you still get a good grade on your test. All right, the metric conversions. There's a lot of them here. I am going to pick and choose and go through and do some of these. If I skip over one that you would have preferred that I do, then my suggestion is you email me, and then I will send you the answer or send you how to solve it. If by chance you're like, okay, this is way too easy and I don't want to waste my time as he goes over it, why don't you fast forward? You can get to today's lecture and skip right over this part. I think number 3 would definitely be worth doing. I think question number 8 would definitely be worth doing. I think questions 9 and 10 would definitely be worth doing because those ones kind of stretch out our metric prefixes. So starting with number 3 says 8.2 mm equals blank km. Okay, so we recognize that m, the last m, stands for meters. Then the first m is the prefix must be milli. So I put my blue arrow there. Then the answer units that I want are km. So kilo is what I'm going for. Okay. Then what we do is we count the number of places that we move our decimal to get from m to k. 1, 2, 3, 4, 5, 6 places to the left. So therefore, when I take my 8.2, I want to go 1, 2, 3, 4, 5, 6 places to the left. On your homework, if I have seen it written out like this with all those bubbles underneath, waves underneath, great. But on your test, clean it up. You should rewrite it as 0.1234582. Sometimes on tests, when they're done cleaning like this and I see a student off by 1 0, I don't mark it wrong. I give full credit because you have the idea correct. And that's really what's more important to me at this point. Okay, so here's the answers for all of those. Then I said I wanted to do number 8 because it goes down into the pico. Pico is a very, very small measurement of meters. And then millimeters is still small, but it's a billion times larger. Think about a millimeter. If you have a ruler at home that shows the 0 to 30, it's going to say mm maybe possibly on it, which those 0 to 30 is not the mm, that's the cm. Those 30 are 30 centimeters is about 12 inches. It's those little tiny lines on there are the mm. Those are the millimeters. So if you think about the distance between those two, between two of those little tiny lines, you know, it's the width of a piece of string, maybe real thin string. A picometer is a billion times smaller. I mean, when we get to picometers, even an atom would look, I don't know, maybe more just normal size. I think that like a typical like hydrogen atom is measured, its radius, it might be measured in picometers, but it's early in the morning right now, so all that kind of stuff, of course, I don't know. 5.2 picometers. So I'm down here, blue arrow. I want to get to millimeters, that's here, green arrow, and then count the movements. And remember those dots count, they just don't have names. So 1, 2, 3, 4, 5, 6 brings us to micro. 7, 8, 9 places to the left with my decimal. 5.2, 1, 2, 3, 4, 5, 6, 7, 8, 9. In class, if we were doing this for candy, what I tell my students to do is instead of trying to read this, because you can't go 0.00000000052, nobody knows how many zeros to put. We would say 0.8052. Then everybody can look and go, oh yeah, I have 8 zeros as well. For those of you who are scientific notation inclined, you might write this as 5.2 times 10 to the negative 9th power. And if you're wondering how I figured that out, Google it. Okay? These kinds of things don't come up on a test. On the test, I'm grading you that you can do some metric conversions on this first chapter, and then we don't really see it much other than in labs. And ours weren't going to, of course, go this small. Question number 9. 7.2 micrometers, we want to take that up to centimeters. So micro is located here. Centi, I'm just going to keep the same colors now just to speed this up. Centi is located there. 1, 2, 3, 1, 2, 3, 4 places to the left with my decimal becomes 0.1272 centimeters. Question number 10 says 1.2 kilometers, that's located here. We want to change that to nanometers, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places to the right, this time with our decimal. So there was the decimal right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, did I say 12? 10, 11, 12? Yeah, I said 12, okay? Or some of you might say 1.2 times 10 to the positive 12 nanometers. I think that's good enough. If you have any questions on any of these that I skipped over, they're good questions. Please ask them, and I can go over them for you. All right, so partly why I wanted to just cover one section today is because this is big stuff. You know, we need to understand velocity and acceleration, how they relate to each other, how to solve the problems. Even though today we're not going to be solving the acceleration problems, we're just going to set them up. Your textbook wants to use chapter 3 as a kind of like, let's ease people into physics and make sure they feel good, warm and fuzzy about physics, rather than, you know, jump straight into the fire and then have people have a bunch of anxiety. So we set up the problem, but we need to know the relationship and everything. So obviously we talked about velocity on our first day. It is speed in a specific direction. Maybe for those who are video watchers still, we might want to point out that in your lab, it says something about your motion that you were doing. That could be considered a velocity? And I want to say yes, because you ran in a specific direction. You moved, you walked, you cartwheeled, whatever you chose to do in a specific direction. So therefore, your speed could be considered a velocity in those problems. Now, this is one of those places where in physics we become very zen, is recognizing how to find average velocity. Because in real life, things rarely can maintain a constant speed, right? It's difficult. You know, when would a car be driving at a constant speed? Maybe in the lab, could we say that you traveled at a constant speed from the start point to the end point? Of course not, because you started at 0, right? You weren't moving when you started your stopwatch. So therefore, at some point in time, you're traveling faster because of the fact that at the start you're traveling slower, so that your average is all of the accumulated different speeds along that time, right? So just kind of keep that in mind. So how we find average velocity, this is the part, and I think that it would be important for you if you're copying this in your notes. Remember that you're following along on Classroom or with my website, that you can see these notes, and I have all those red text boxes where I explain all of this stuff out. I think all of that's great. I think it's good for studying purposes. I don't really want you to copy them down into your notes other than what you see here. But I would like you to underline total distance divided by total time. And not only that, but I'm even going to add to the equation and say D total and T total. It's the first real Zen moment in physics, is knowing that we can find the average of anything by just taking, if it's a formula like this where it's division, you just take the total distance divided by the total time. We'll talk about that again with acceleration in a few moments. As opposed to instantaneous velocity, we won't be solving that today, but there will be times where we talk about it. That is where we actually talk about the speed at that particular moment. But because it's velocity, we also have to mention that there's a particular direction with it. So like when you're driving in your car and you're on the freeway, you might look down. Remember, don't look down for long, so you're paying attention. If you look at your display, possibly there's a way to pull up the GPS with it and what it's going to do. I mean, some cars, my current truck right now doesn't show me what direction I'm pointed, but my last truck did. It had it on the rear view mirror, and it would say north or northwest or whatever. So that's kind of the car's attempt to turn your speed into a velocity by telling you which direction you're pointed. Example 1, standing on a roof 100 meters above the ground, a kid drops a water balloon, and 4.5 seconds later it hits the ground. What was its average speed? Obviously, the balloon wasn't traveling at a constant speed. It was speeding up. It was accelerating because of gravity. right? In a little bit, we're going to call that free fall. It's part of chapter 5. You'll do a lab on it. Maybe not with water balloons, but I'm always open to interpretations on the lab, so you can do things however you want. Okay, so first of all, being Zen, maybe our other Zen, other than the total distance and total time, is knowing that there's a money question, that we're solving for what is the velocity. I already have that written down over here. Then you recognize what your givens are, and you probably spotted the givens by the units that were there, because they don't actually say the roof is a distance of, they don't say the water balloon hits the ground in a time of, so you have to be able to interpret that, and the units are the quickest way to that. Those three things are related to each other by V. I'm going to call this V av is equal to distance total divided by T total. Okay? If it's accelerating uniformly, there is an interesting thing here, is the speed at the halfway point does equal the average, because you're averaging zero speed with fastest speed, speed at 1 second with speed at, let's call it why would I use 4.5? If I could have used 5, then we could use whole numbers. But you get the idea that you're averaging all of these speeds together, and if it's speeding up at a constant rate, we call that uniform acceleration. Then right at the middle, its instantaneous speed is its average speed. Okay? I don't ask that on any questions, but we used to give something called the Golden State exam, which was a state test back in the late 90s, early 2000s, and they always would have a lab component with it. And I remember one of the labs they did, which we're going to do something similar because it's, they're made of at-home materials. Ask that question. So that's about the only time it shows up. So total distance divided by total time. There it's nice and written out for you. Look at your notes, copy down what you feel you should copy down. Red text box aren't necessarily great, but sometimes these kinds of words, even if they're in red, they're worth including. Hair grows at an average rate of 3 times 10 to the negative 9th meters per second. All right, find the length after 1 year. Okay, so we recognize length. That sounds like there's a question. Find the length. Length is a measurement of distance. Now we have a money question. Hair grows at an average rate. Now I don't see the word velocity, but I see these units here for velocity. So rate really does mean velocity in distance time problems. After 1 year, it's not written in seconds, but at least we do recognize that that's a time. So we do have the same variables that we always want. Distance equals velocity times time. The issue that we're going to have with this problem is if we put in the velocity, 3 times 10 to the negative 9th meters per second. Remember, if I'm going too fast for you, pause it, copy down what you need to, and start it up again. We need to multiply this by time, but I'm going to put this in red because we aren't copying this down. You can't put in 1 year here because the problem is the units aren't compatible. They won't cancel out. So this 1 year has to be converted into seconds. This never comes up in this class other than on homework assignments and things like that. So if you just want to Google how many seconds are in 1 year, please be my guest. Otherwise, if you look ahead to the slides, I did all the multiplication for us here, and we get 3 times 10 to the 7th seconds. So we're looking at 30 million seconds are in 1 year. Well, that seems like a lot of seconds, but that makes sense. That'd be that many seconds in a year. We have a really, really slow rate of growth of the hair or velocity of the hair. Put those two things together, and then we end up with an answer that now seems kind of reasonable. I definitely would say this is reasonable because I've been growing this since October of 2018, and including also the rate that it falls out, which is going to affect it. There's getting to be maybe the longest hairs could be coming in around almost 15 centimeters, right? So it seems like a legitimate answer at least, and gives me an opportunity to talk about my hair. What if, because a lot of you already had hair, longer hair, and then you're planning on growing your hair longer. What if the hair was already 10 centimeters long when you decided you're going to grow it out longer? How long would it be after 1 year? Okay, well, if it already was 10, and in 1 year it's going to grow another 9, sounds to me like the answer is easy. The answer is 19, all right? We don't need an equation for that. except for problems in physics aren't always so easy. So therefore, having an equation that helps us solve when our starting point is not 0, right? When we talk about the car in the problem, in fact, I think that's what my next example is. A car passes a sign that reads 213.8 kilometers. They've got the cruise control set at 88. What would a sign read a half hour later? We know that in that half hour, they've traveled some distance, and we know that we can find the distance that you travel in a half hour by just taking distance equals velocity times time. And we'll know that distance, but that's not what the sign reads, because the sign has to read that much distance more than 213. So an equation that would solve that would look like what you see here at the very top. D final, what the sign reads, equals D initial, what the initial sign reads, plus how far you've traveled as you go from first sign to second sign. Okay? So in this one here, we could say, since I already drew a beautiful picture here, why would I write down my givens on the side? I think I did this on the next slide, but in the end, if you draw a picture, please write on your picture. So DI equals this, DF equals money question. Okay, now the weird thing is what does the sign read? Obviously there's a question right here. The time is written right into the money question, but it's not the money question. Time's given. Time is half hour. So looking at how my units are working, maybe I want to say that my velocity here is 88 kilometers per hour, and this was already written in kilometers. This is already written in hours. I feel like I've got compatible units if I just keep this in kilometers and hours and not switch to meters and seconds. You can do that, of course. I'm not going to give you extra credit for it, but it's a good idea. But in the end, one answer is as good as the other. So D final equals D initial, 213.8 kilometers, plus V, 88 kilometers per hour, times a half hour. I'll just call that 0.5 hours. Now, for those of you keeping track of the units, hours cancel out hours, which means that this number here is a kilometers, which means it can be added to the other kilometers. Half of 88 is 44. I don't think I need to show any more on this slide. Let's go to the answer slide, which came out to be 258-ish, I rounded, which is fine, kilometers. Okay, so now we have a little bit more substantial equation. I like that better than just distance equals velocity times time. To me, that feels like middle school. This feels like physics when we start seeing it like that. All right, the second half of today's notes deal with acceleration. We all know what acceleration is because you all know speeding up, right? You all know that, leaving a stop sign, dropping an object, these are forms of speeding up, and so we would call that acceleration. We also need to include slowing down as a form of acceleration. It's just that mathematically, the scalar, remember scalar means the magnitude of something, the scalar is negative, so we just have to know that A is negative. Now, if you forget that, number one, on the setup questions for your test, I give extra credit if you notice that the acceleration is negative. And that's because in chapter 5, if you forget the negative sign, there's many times where the equation forgives you. It'll just make like the distance traveled come out to be negative. And you're like, well, you can't travel a negative distance. That doesn't make sense. So the equation kind of forgives you. Some other things to point out here about this is, number one, it says delta V over T. Delta anything in this class, in science especially, is a shorthand way of saying that something's changing, which really means that you're subtracting an initial from a final value. So don't be bothered by that because we're going to see plenty of deltas in this class, okay? V final minus V initial. Now, the units of acceleration, I want you just to memorize that the units of acceleration are meters per second squared. When you see it looking like this, when you see it looking like this, that you know that those are the units of acceleration. Here's how they work. You don't need to know this. When you take your numbers, so you're going to be doing a delta V. So in other words, whatever you solve here, you're going to get an answer in meters per second for velocity. When you subtract two velocities, you get an answer that's a velocity. Then you're going to be dividing this by a time, which is measured in seconds. So you have a fraction inside of a fraction. And what they taught us in middle school, maybe Math 1, is you take the bottom and you make it into a fraction, then you flip it over to bring it on top. So this becomes meters per second times 1/seconds. Then, even though these aren't numbers, they're variables, they're units, you can multiply them. 1 times m is still just an m, and seconds times seconds is where we get seconds squared. Okay, so now that I've written that down, I'm going to take this out of here and talk about the concept. So one way of looking at this is to say the meters per second, and another way of looking at this is to recognize the units, meters per second squared. I'll talk about both of those as we get into our setup problems here. This is it, last problem. Set up only. On your test, there's going to be questions that say set up only. If you decide to solve them, that's fine. I won't even look at them. Officially, we don't have the equations to solve them. I don't want you to attempt it because I don't want you to not get an answer and then get frustrated and quit. I want you to finish your test, you set up the problems, feel warm and fuzzy inside, get your A for the start of your remote learning physics class, and be okay with this until finally we get to come back together and joke and do our labs in class and all that good stuff, okay? Let's get an A as we finish out this part. Okay, so first thing is, I'm still a fan of pictures, and I could draw this out for you, but I've done such a nice job online, is I drew a picture that shows a car is traveling. So I put a car on one side, traveling towards the other side, and they say that the car is slowing. So if I draw velocity vectors for this, to me it sounds like then its fastest speed should be at the beginning, and these velocity vectors should get shorter and shorter as I progress down this path. You don't have to have that, but you know, it's nice. It's a good visual for yourself and for somebody reading your work. Okay? A driver is traveling at 25 meters per second. We know that that's a velocity. I should stop here for a moment and point out a couple things here that probably says in the red text boxes on this problem here. Is there are 5 motion variables that are often used in physics: distance, acceleration, time, initial velocity, and final velocity. Okay? So far, we also broke distance up into initial distance and final distance, and that's common when things travel at constant speed because then there's no acceleration. So then they use di and df as the other variables, and vi and vf are really just the same thing, right? Because if you're not speeding up or slowing down, your initial speed and your final speed are the same number, so you wouldn't need to differentiate between them. But once you have acceleration, your initial and final speeds are different. Now your distance could be different, but we're just kind of looking at the distance that was covered during the time that we looked at the problem, and therefore we don't really need a DI here. But you know, fancy physics equation sheets might write out some of the equations with a DI in it. That doesn't happen for us. It's not on my equation sheet, and when we need to explain that better, I'll explain that better. All right, driver is traveling 25 meters per second. That's a velocity. So we have to decide which one of these it is. So that's where you have to look at the context of the problem and say, okay, odds are it came first in the question. It's probably the initial velocity because, you know, 99.9% of the time that's true. Maybe not that often. 98% of the time that's true. But definitely with the context of the problem, it was going that speed and slowed at, okay? Now, they don't tell us that 8.5 is an acceleration, but it has that new unit that we're now aware of, meters per second squared. So I'm going to put in 8.5 meters per second squared here. By the way, if you don't draw a picture, if on your test you just write down the givens on the side here, you don't even have to include the units. I don't take any points off for not having the units. My point is I want to see that you know what each of the variables was. So I don't need to see the units. I don't grade the units. They're nice to be there though. What is the total distance? Sounds like a money question. Question mark. Distance, question mark. Before the car moves, before stopping. Okay, stopping is one of those fancy words. Tells us that we have a velocity that's equal to 0. So it's going to slow down until its final speed is 0 meters per second. Okay? Now, I know there's something bugging right now. You're thinking, what about time? There was no time mentioned in this problem. They didn't tell us how much time elapsed for this problem. They didn't ask us how much time elapsed for this problem. So we're going to say that time is not mentioned. There's a reason for that. Not mentioned. I don't even care if you just put NA and anything like that. There's a reason for that, is we put 5 motion variables because there's 5 motion equations. And there's some fancy math called system of equations, which needs that. But for all of us, for all of our problems that we solve in chapter 5, all of the equations have 4 of the motion variables and then 1 that's not part of it. Therefore, all of the questions that we solve have 4 motion variables and then 1 that's not mentioned. Okay? So you'll always be given 3 and you'll solve for a 4th, and the 5th one's not mentioned. So you read everything like this right here, you're going to get full credit. And this problem on your test, because we have fewer questions on our test now, is probably worth 15 points. That makes each one of these worth 3 points each. Okay? Drawing a picture is nice, not required. You can just put them like this. Now, I do give extra credit. The extra credit on this question is the fact that because the car is slowing, if something's slowing, that you tell me that the acceleration is negative. Not required. Full credit if you don't have the negative there, but extra credit if you do. You guys are awesome. Chapter 3, homework number 2. These are the problems. You're going to be just setting them up, except for number 8. I want you to solve because that's using the df equals di plus v times t. This is due on Monday because right now we're on Thursday. Your lab is due on Wednesday, and I'll bring that up again on Monday. And if there's a bunch of questions, I'll try to answer them by email. But at the very least, if I'm getting the same question over and over again and I haven't answered you, don't be freaking out. By Monday, I then probably am addressing it in the notes. Unless, of course, I do the notes later this week and I don't actually get that question to me, because time is a weird thing right now. Everybody's on a different time as to when they're doing stuff, unless they're doing stuff live. I'm not. All right, guys. See you next time.